part 2 of the study guide. It says use the graph to determine the x and y intercepts. So just to review, the x and y intercepts are where you cross, is that what happened? Yeah. The x-axis. So the x-intercept is there and the y-intercept is there. And so we just need to count. So the x-intercept is negative 1, 0. And the y-intercept is 2, 0. Okay? So just need to remember that the y-intercept is on the y-axis and the x-intercept is on the x-axis.
Wait, so we don't have to do any work?
No, it's just reading the graph. See, it says use the graph to determine. So really, I just want to know if you know what the intercepts are. Okay, number 8. Imaginary numbers. It says write the result in standard form. So be careful with this. 7i minus 3 minus I. So I'm going to distribute my negative sign. This turns out to be plus 3 because it's minus a negative, and plus I. So in standard form, it will be 3 plus 8i Okay, for number 9. We would do the same thing with the negative 3. I'm sorry, Shelby?
Would you do the same thing as the
Yes. So it's 9 plus 4i, and then it's minus a negative, so that turns out to be plus 5, minus a positive, so minus I. So 9 plus 5 is 14, and 4i minus I is 3i. Okay, for number 10, 7 plus 3i plus 2 minus I. 7 and 2 is 9. 3i minus I is 2i. So I guess the toughest part is remembering to write these in standard form. Now we're going to find the product. And I do expect really good grades on these imaginary number pieces because we did spend some time on that. You do need to FOIL. So 5x times 4x is 20x squared. 5x times 3 is 15x. Negative 11 times 4x is negative 44x. Negative 11 times 3 is negative 33. Collect like terms. And we get 20x squared. 15x minus 44x. What is that? 9. 39? No, 29. Minus 29x. Minus 33. Is 29 right? Just checking it with the calculator. It is. Okay. All right, so again, we're FOILing. 7x times 3x is 21x squared. 7x times 4 is minus 28x squared. Oops. This is really supposed to be x to the 4th, isn't it? Do you see I missed that? See if we can get that tiny one and erase that tiny bit. This is supposed to be x to the 4th. Because it's 7x squared times 3x squared. Minus 28x squared plus 36x squared. Minus 48. So collecting like terms, negative 28 and positive 36 we'll put together. So that's 21 x to the fourth plus, what's 36 and 28? 8x squared minus 48. Okay? So, question 13 takes a little work because you have to simplify this. Remember, to simplify this, you have to factor the 8. So you're going to factor the 8 into 2 times 2 times 2. And so a pair of 2's come out times the 6 that's there. So 2 times negative 6 is negative 12 square roots of 2. Okay, so now let's do that middle term. So this is 18, or 3 times 3 times 6. So the pair of 3's come out. Multiply that times the negative 4. So that also, that's 3 times 3 times 2, isn't it? Not 6. So that's also 12 square roots of 2. And finally, 32 is 2 times 2 times 2 times 2 times 2. It's 5 2's. So you have a pair of 2's, a pair of 2's. So 2 times 2 is 4 times the 10 gives me 40. So that's plus 40 square roots of 2. Now you see that these are like terms because we have the square root of 2 for each of them. So negative 12 minus 12 is negative 24. Negative 24 and 40, 16 square roots of 2. Okay, that's a tough one. All right. Next we need to rationalize, because you're not allowed to have I in the denominator. So let's see if we can rationalize this. Still having a little trouble with my lines. Let's see if that helps. So the rational, to rationalize this, I'm going to multiply it by 4 minus I, it's called a conjugate, over 4 minus I. And I have to FOIL the top and distribute, FOIL the bottom and distribute the top. So we have 3i times 4 is 12i. And 3i times negative I is negative 3i squared. And for the bottom, we're going to have 4 times 4 is 16. And this is going to be minus 4i plus 4i, which is the way we planned it. If you don't get that, you didn't pick the right conjugate. I times negative I is negative I squared. So these cancel. And we have 12i plus 3, because I squared is negative 1. And 16i, or 16, plus 1. So in standard form, your answer would be 3 plus 12i over 17. And those three numbers don't have a common factor. Okay. The conjugate for number 15 is 5 plus 6i. And we have to FOIL both the top and the bottom this time. So 2 times 5 is 10. 2 times 6i is 12i. 2i times 5 is 10i. 2i times 6i is negative 12i squared. And for the bottom, 5 times 5 is 25. 5 times 6 is 30i. 6 times 5 is 30i. 6i times 6i is 36i squared. And it's negative times positive, so it's negative. So we're going to take a look at collecting like terms. These cancel on the bottom. And we'll have 25 plus 36. What's 25 plus 36? 3, 4, 5, 6, 61. And on the top, the 12 becomes plus 12. So 10 and 12 is 22. And 12i minus 10i is 2i. And so that's what we have in standard form. 22 plus 2i over 61. Okay, number 16, these denominators are the same. So we just combine the tops. So x squared plus x squared is 2x squared. And negative 2x plus x is negative x over the same denominator. Remember, when you add fractions, you don't change the numerator and denominator, you leave them the same. But now we need to simplify that. So x times 2x minus 1 over x times x plus 8. The x's cancel, and so my answer is 2x minus 1 over x plus 8. Okay, determine the constant that should be added to the binomial so it becomes a perfect square trinomial. Then write and factor the trinomial. So remember what we do is you take half of b, so that's 13 over 2, and square it. So we're going to have to add, this is always adding, 13 times 13 is 169, 4 times 4 is 2. So I need to add to that 169 over 4. Now a lot of you like to turn that into a decimal. It's much easier to do if you leave it as a fraction. Because now we can see that this is going to be factored as x minus 13 over 2. So this was the b, this was the b over 2, and this is b over 2 squared. So that's what we had for that one. And we did that one in